Today, students, we are doing lesson 5 from the General Science textbook for Standard 6. Substances in the surroundings, their states and properties.
This video was made just for you. Do remember to like, share and subscribe.
Substances in the surroundings, their states and properties. We are surrounded with substances. All substances are present in the three states, namely solid state, liquid state and the gaseous state. And all substances are made up of matter. So what is the property of matter? The property of matter is that matter occupies space and matter has mass. So all substances, whether they are in the solid state, liquid state or gaseous state, will occupy space and have mass. Now we have already learned about the three states of water. So can you recall? The name the solid, the liquid and the gaseous state of water. So the solid state of matter, the solid state of water is ice. The liquid state is water and the gaseous state is water vapor. Now if we heat the ice, it will change to water, isn't it? And if we heat water, it will change to water vapor. But it is the other way around is also true. If we cool water vapor, what will happen? It will change to water. And if we cool water, it will change to ice. So now let us understand the change of state of substances. So we have already learnt about water. Now let's learn about some other substances. Now let's try this activity. For this, okay, take pieces of wax in a bowl and heat them on a candle or a spirit lamp. Okay, if you are in a laboratory, you could do it with a spirit lamp. Otherwise, if the spirit lamp is not available, you can use a candle to heat the wax. So take it in a pieces of wax in a bowl and heat it. To follow the pictures given to you alongside. What will happen? How do the pieces of wax change? Okay, so what will happen to the pieces of wax? So they will change into the liquid state. What was the initial state of wax? Initial means earlier state of wax. What was it? How was it before heating? It were into chunks, isn't it? They were pieces. So it was in the solid state. And what did it convert into? What happened on heating? On heating, it converted into the liquid state. Now, keep the same bowl in a cold water. So, after you have heated this, okay, now take it and keep it in cold water. So, what do you think will happen? Again, the wax will solidify and it will change to its solid state. So, wax again has changed to the solid state. So, what have we learned from this little experiment? We have learned that when a substance changes from one state to another, the process is called change of state of substance. So when it changes from one state to the other, solid to liquid, liquid to gaseous, or the other way around, from gaseous to liquid to solid. So that process, the whole process is called the change of state of substance. So remember the statement, children. Okay, so when a substance changes from one state to another, the process is called the change of state of substance. Now let's reflect on these questions. Okay, now can you tell? Read this list of substances. So which is the list? Spirit, camphor, petrol, ghee, coconut oil, naphthalene balls, ammonium chloride, which in Hindi is called Navsagar. Okay, so what will happen to this? Now which one freezes in winter? Freezes means it will become solid in winter. Which do you think will become solid in winter? Okay, look at this. This is ghee. Okay, so ghee again will become solid in winter. Coconut oil, again it will become solid in winter, isn't it? Now, which liquids have you seen change into vapor? Which liquids? See, spirit, isn't it? Spirit is in the liquid form. So which is the best examples of spirit around your house? Okay, yes, you have perfumes around the house. So there is spirit added to the perfumes. So we know that we keep our perfume bottles covered. immediately, isn't it? So as soon as we use it, we cover it. Why do you think so? If you had kept the perfume bottle open, what would happen? Everything would have evaporated, isn't it? So perfume was in the liquid state because there was along with the fragrance, they add the spirit in it. So also what happens is, as soon as you keep it open, the liquid will change to its gaseous state and will evaporate. Okay, so also we have seen that our paints, not only the paints that you all carry to school and all that, even the big paints that we use for our homes and all that, we have to keep it always covered, isn't it? Otherwise what will happen to the paints? They become solid. Now why did they happen? Because there was spirit present in it. Okay, they added spirit, so as soon as you keep it open, the spirit evaporates and so the paints become solid. Okay, so therefore we have to keep it covered. So spirit is something which changes from liquid state to its gaseous form. Now which solids directly change into the gaseous state? Okay, your mom must have kept a lot of naphthalene balls for the cockroaches to drive away, isn't it? In the cupboards, in the kitchen cupboard cabinets, in our wardrobes, we keep it here and there, isn't it? So after some times you have seen that they have become smaller and smaller and smaller. Why did they become? Again, they have changed from one state to the other. So from which state have they changed? They changed from the solid state to its gaseous state directly. So also with camphor, you must have seen your mom or your parents, elders lighting the camphor balls for, when you're doing some puja or something. So this also changes from this solid state to its gaseous states. Now what did we learn from this little activity that we had just reflected on? The ghee, the spirit, the naphthalene balls, the camphor balls. So we learned that the state of substances changes if it is heated or cooled. We have already seen with the wax. Now every substance in our surroundings is found in either the solid state, liquid state or gaseous state. So all substances, okay, are in our surrounding are present in either of these three states. Either they will be in the solid state, or they will be in the liquid state, or they will be in the gaseous state. So these are the three states of matter that we find all our substances in. Now let's reflect. Let's go to the past and see. In the 19th century, the scientist J. Willard Gibbs showed that the characteristics of properties of a substance depend on its physical state and the arrangement of particles in it. Okay, now what does it mean is, what did he find? Now we know that the substances are available in three states: solid state, the liquid state and the gaseous state, and all substances are made of matter. So there are molecules present in it, and what happens to these molecules in the solid state? They are tightly packed, okay, very very tightly packed, so therefore they don't change the shape. But in the liquid state, they are little bit loose, so when the liquid we pour it in the container, it will take the shape of the container in which it is. Okay, but whereas the gaseous state, they are even very very lightly packed, okay, very loose. Okay, so they will move any which way. Sometimes they evaporate, they move away from everything. Okay, we cannot tie up. So that is what he found out, and he says that their properties, okay, the characteristics of the properties of a substance depend on its physical state, so in which state they are, and the arrangement of the particles. So in what arrangement the molecules are present: solid, liquid and the gaseous state. So that is how the characteristics of the properties depend. Now let's understand the differences between the three states of matter, namely the solid state, liquid state and gaseous state. What is it? Why is it different from each other? How it is different from each other? So first let's look at the solid state. Okay. Now let's look at the piece of iron. Piece of iron is in the solid state. Now what is its shape? Has a shape of its own, isn't it? Iron will always retain its shape no matter where you keep it, okay, or how long you keep it. So it is not going to change its shape unless and until you do something to it. Otherwise, if you keep it as it is not going to change its shape. Then that is, it retains the shape. no matter how it is kept. Okay, so how it is kept, no matter how or where you keep it, nothing is going to happen to it. Now, what about its volume? Has a definite volume. Okay, so again, the volume also will not change. That is, the mass present in it also will not change. And solids like sugar, sand, when poured on a flat surface from a heap. Okay, so again, if you pour it from one heap to the other heap, okay, the volume will be the same, isn't it? The volume will not change of the solids. So sugar and other sand and all that, they are fine particles, okay, but yet they are in the solid state. Though they are fine particles, they are in the solid state. So again, solids, what are the two things is they retain their shape no matter where it is kept, as well as they have definite volume. Now let's look at liquids. Now liquids like water, spirit, oil. Okay, now all this, does not have a shape of its own, isn't it? We know it takes the shape of the container in which it is kept. So we have seen water, we have seen all other liquids, oil, spirit, all these things. It will take the shape of the container, and it has a specific volume. So again, it has a specific, it's a definite volume, and occupies definite portion of the container. So that container, it will occupy the space in the container, and it will spread on a flat surface on pouring, isn't it? When we pour the liquid, it will spread out again. So here what happens is, when we pour it on a flat surface, it cannot hold the shape, because the place doesn't have a shape of its own, isn't it? It's a flat surface, so therefore it will spread out as much as it can. Okay, so it will spread on a flat surface on pouring and flows downwards along a slope. So if you put it on a slope, it will flow in that direction. So these are some of the properties that we see. Okay, so it has a specific volume, occupies definite portion of the container, and if there is no container present, if you put it on a flat surface, it will spread. So spread till it is flat, how much it can spread out. But if you tilt that, the flat surface, or it is on a slope, it will flow towards a downwards direction. Now let's understand about gases. Now gases is the most best example is air. Okay, we are surrounded with air. Does not have a shape of its own, isn't it? So air is everywhere, it will spread out. It does not have a shape of its own at all, and occupies all the available space. So wherever it can spread, it will go out. So occupies all the available space. Does not have a definite volume. It does not, again, no volume of its own. Okay, a definite volume. On changing the pressure on a gas in a closed container, its volume also changes. Suppose we have, compressed it, taken it in a closed container. Now normally we have seen oxygen cylinders, hydrogen cylinders, isn't it? So you have seen the cylinders. Okay, even we have cylinders of the gas that is available in our homes. Some of you may be having the cylinders till now. Okay, so the cylinders, the gas is filled. What they do is they compress the gas, so they put it under pressure. So on changing the pressure on the gas in a closed container, its volume also changes. So the volume, now the whole gas is contained in a container, so therefore the volume will change. Otherwise, if you keep it open, it will not have a particular volume. Okay, heat and change of physical state. Now we already saw in the example when we heated the wax, isn't it? What happened? As soon as we heated the wax, it changed from solid state to liquid state, and when we cooled it, what happened? It changed from liquid state to solid state. So what exactly happens? Now you have learned that change in the physical state of a substance is an effect of the amount of heat in it, isn't it? As soon as we put heat to it, we applied heat to it, to the wax pieces, it melted, isn't it? So it changed from one state to the other, and on gaining heat, the substances changes from solid to liquid and liquid to gases. We know in the case of water also, when ice, it gets heated up, it will change from solid to liquid, and when we heat the liquid, it will change from liquid to gaseous state. On the other hand, when we cool it, okay, that is when the substances cools or loses heat. Cooling means losing heat. Okay, so it will change from gaseous to the liquid, and to solid state. So from gaseous state to liquid state, and from liquid state to solid state. Okay, now let's understand this with this help of a little diagram. Okay, so solid will change to the liquid on heating, and liquid will change to gaseous on heating. And on the other hand, when we cool it, that is, the heat is taken away from it. Okay, so gas will change, the gaseous state, it will change to liquid state, and from the liquid state it will change to its solid state. So this is what happens with the effect of heat. The change of physical state happens. So because of the heat, either applying heat or taking heat away, there is a change of state. Now let's reflect on this question. Can you tell, does water change into vapor the moment we place the vessel on the stove? Okay, we know that water when heating will change from the liquid state to its the gaseous state. That means water has changed into water vapor. Okay, so does it change immediately the minute you keep it for heating? Will it change it? Reflect on this question. What do you feel? Does water kept in the fridge change at once into ice? Now, suppose you must have often kept water, no, in the fridge part of the fridge. Okay, that is the freezer part of the fridge. So immediately does it turn into ice? No, no. All this takes time. It takes a little bit of time. Only after a certain period of time will it change. So what happens is, a specific amount of heat must be gained or lost before the state of a substance can change. Okay, what this means is, when you keep the water for boiling, okay, or on the heat. Okay, so what happens? The amount of heat, a certain amount of heat it should gain means it should acquire, it should take, only then it will start changing its state. So from the liquid state it will change to the water vapor state, okay, the gaseous state. Okay, so only after a certain amount of heat it has gained. Or when we kept the water in the fridge, what happened is, it starts cooling down. So cooling means the heat is going away from the water. Okay, so only after a certain amount of heat is lost, okay, that is, after certain amount of cooling has happened, only then it will change from the liquid to the solid state. So the change in physical state is determined. Determined means it is done. Okay, the change in the physical state is determined by how hot the substance becomes on gaining heat, or how cold on losing heat. Okay, so this tells us, okay, that how much the substance has gained heat, acquired heat, or how much it has lost heat. So now, how do we tell how hot or cold a substance is? So how can we just tell by looking at it? Sometimes yes, by looking at the boiling water we can understand, because we know that water has boils at 100 degrees Celsius, and by looking at the ice cubes we know it is 0 degrees Celsius. Okay, so we know that water freezes at 0 degrees Celsius, but how did we come to know all this? How did we come to know about 100 degrees and 0 degrees Celsius? Okay, so the temperature, let's learn about the temperature and the thermometer now. So how to judge how hot it is or how cold it is? When a substance gets heat, it becomes warm and then hot. So we put our hand or finger in the water to judge how it is, but it is not an accurate measure, isn't it? It is not perfect, it is not accurate. So just by touching it, just by looking at it, we can't accurately or perfectly tell that how hot this substance is. So besides, if the substance is very hot, we could get scalded. Scalded means burnt. Our fingers or our hand can get burnt if we try to touch something. Suppose there is hot oil burning, okay, boiling on the gas, and we try to judge how much it is. No, that's wrong to do. Don't do this. Okay, you may get burnt. So we use a thermometer. So a thermometer is used to measure temperature. And if you look at all these pictures over here, you will see these are the various types of thermometers that are there. Okay, and degree Celsius is a unit of measuring temperature. So there are two units of measurement, that is, one is the degree Celsius and the other is the Fahrenheit. But normally we use degree Celsius in India. Okay, we measure all the temperatures in degree Celsius, and there are several types of thermometers available. Just like I showed you over here, there are so many types of thermometers available, but nowadays we use the digital thermometers frequently. So digital is, it gives us directly in numbers. Okay, so this is the digital thermometer that we use. Earlier all these thermometers were used where there was mercury, and the mercury would rise up, and accordingly we could measure the temperature. But now it has become very super simple. Okay, these are battery operated or electric operated, but mostly are battery operated. So these are the digital thermometers that we use to measure the temperature. So immediately we can understand how hot or how cold a particular substance is. Now students, try this activity. Okay, take a thermometer from the laboratory, or if you have a thermometer at home, you could just try that at home too. Now the bulb of its lower end is filled with mercury. We have just seen the mercury that is present over here. Okay, so this is called the bulb. It has mercury in it. So as soon as this is, this will tell you exactly how hot or how cold it is, and there are all these markings there. On one side it will show in degrees Celsius, and the other side it will show in degrees Fahrenheit. Normally we measure the heat or the temperature of any substance with the help of degrees Celsius. So take the thermometer and you can dip it in the substance you want to measure the temperature of, and you will see that the mercury will start rising up. So let's do this experiment. Okay, now the mercury rises to a certain level in the capillary tube above the bulb. So without placing it anywhere, if you just take it and if you just see it, okay, start reading it without placing it in any substance, okay, you will see a scale next to the mercury column. We just saw that scale, isn't it? There is a scale for Celsius and Fahrenheit, and reading the figure near the level of the mercury tells us the temperature of air around the bulb of the thermometer. So when you just read it without placing it anywhere, you will find you can read the temperature of air around you, okay, in wherever you are, how hot or how cold the place is where you are. Now try to do this. Now hold the thermometer in water so that the bulb is completely immersed in water. That is, it is totally dipped. Immersed means totally dipped, the bulb. Okay, just look at this picture that is given alongside. So it is totally dipped. Now take plain water first, okay, and read the temperature. Note it down in your notebook. Then repeat the activity taking some hot water. Now if you have the chance, but do this experiment in along with your elders or your teachers. Okay, so if you're doing it at home, see that someone older to you, okay, is there present with you, or in school you can do it along with your teacher. So repeat this activity taking hot water and in a vessel, and then you can repeat this with cold water or ice in another. So you can just keep on repeating this experiment or this little activity and note down the temperature each time. So what will you see? You will see that the boiling water, we know, okay, the boiling water boils at 100 degrees Celsius. Freezing water, that is water turning to ice, is 0 degrees Celsius. Air, that is in the winter night, in the winter night is very cold, so it is less than 15 degrees Celsius. Air in the summer afternoon, in the afternoon, isn't it, it's blazing hot in the summers, so it is more than 35 degrees Celsius. Now all this depends on where you are staying, the air, okay, I'm talking about the air, not about the water, and about the water, okay. Water will boil and freeze boil at 100 degrees and freeze at 0 degrees, but what about the air? Air is, the temperature of air will differ at different places. And now inside the fridge, if you measure the temperature inside the fridge, it will be always less than 5 degrees Celsius, and inside the freezer. Freezer is whether you make your ice cream and everything. So it will be less than minus 18 degrees Celsius. So minus means less than 0 also. So less than minus 18 degrees Celsius. And what about our body temperature? Our body temperature approximately means a little here and there. Okay, everyone's body temperature is different. Our normal body temperature, okay, when we have fever it may go up. So our normal body temperature is around, okay, approximately 37 degrees Celsius. So these are the things that we can easily spot around our place: water, air, things inside the fridge, our body temperature. So you could measure all these things and find out for yourself. Now whenever you are doing an experiment, be very careful. If you're holding a flask, okay, this is a conical flask, so always this is the right way of holding it, at the neck of the conical flask, and don't try to dip your hand or touch it anywhere else. Okay, you could get burnt or scalded, or it could contain any sort of chemicals which you are not comfortable with. So be very careful about it. Please solve the exercise given to you at the end of the chapter. To check your answers to all the textual questions and for the summary, meanings, other question answers, and for free worksheets, visit our website at www.jkacademypro.com. You'll get the link in the description box below. Do remember to like, share, and subscribe. This is end of part 1. For a complete lesson, do watch parts 1, 2, 3 and 4. You'll get the link in the description box below.